All right, here's problem 66 for you. In this one, um, that's when we have a force, I guess the pressing force. It's not really a push or a pull. I guess it's a push. But anyways, this FP is applied to the block. The way they drew it for you, they put a 30-degree angle theta right here. So that basically makes it 60 degrees. And the way we draw free body diagrams, we start all of them in the center of an object, as you know. So this case right here shows that the object is moving. Look at this one. It's moving downwards. Um, and the way you can guess that it's moving downwards is that I'm pressing with this force, but the force of friction is going upwards. So, and they told you that the object is sliding with a constant velocity or constant speed, if you will. So here we have this force at an angle, so therefore it will have two components. It will have a horizontal component and a vertical component. And normal force in this case is normal to the surface because here's the surface where this block is touching the wall, so it's perpendicular to the surface. But it looks completely different from what we're used to because we usually have normal force opposite to force of gravity. It's like a reaction of the surface. But here the surface is on the right. So therefore the reaction from the surface is perpendicular and it's going that way. But anyway, here are our four forces, and the way they kind of balance each other is that forces along the horizontal, which is normal force, and the horizontal part of this force of pull or push, they are equal. And as far as vertical forces go, force of gravity of the block is counteracted by two forces, by force of friction and force of pull or push, whatever. So along the x, they are equal. Along the y, they're also equal. Now, as you know, force of friction is mu times normal force. So here we go. Force of friction is mu times normal force, and normal force from here is Fpx, which is this part. Then I can rewrite this. So force of friction from here is mu times Fpx. Force of pull on y. So here's force of friction, which becomes m Fpx. Force of pull on y, right here. And on the other hand, we have mg. So that's our vertical forces acting together and adding up to 0. Then, since mu times Fpx, again, remember this is a 30-degree angle, that's a 60-degree angle. So Px is basically P, the pull, times cosine of 60. Whereas Fpy, this part, is P sine of 60. Again, 60 degrees right here. So these two forces add up to mg. We're looking for P. That's a number, that's a number, that's a number, and that is a number. So basically what you do is you put P in front of a bracket or parentheses or whatever you want to do. And then that leaves P times mu cosine of 60 plus sine of 60 equals mg. So therefore, in order to find the mg, in order to find the P, I'm just dividing mg by m cosine of 60 plus sine of 60. Cosine of 60, if you remember, is half, and that's 0.25. So half of 0.25 is 0.125. Sine of 60 is 0.866. 39, I'm too lazy to carry a 0, but that should be 3 sig figs, 39.0. And then all of that together equals 39.4. Again, that is the force that you're pressing the block with if your block is moving vertically at a constant speed going up. Now we're going to rearrange it and look at what if you're applying too much force, that your friction drops down and your block is sliding up. The thing is that force of gravity, I just chose not to change force of pull or push or whatever. I just chose to make the force of gravity smaller. It doesn't mean that your object all of a sudden became lighter. It's just, for the purpose of the exercise to save time. Anyway, so now that the object is moving upwards, force of friction is downwards. And now, again, the horizontal part is the same, Px equals normal, but on the vertically we have friction and gravity both working against your pressing force vertical. And then again, force of friction is mu normal force, where normal force is Fpx. Then instead of force of friction, we write that. Instead of force of gravity, it's mg, and Fpy is over here. So that's friction, that's gravity, that's Fpy. Then again, mu. Basically, what happens is your mg and p sine of 60 changed places. And then therefore, in the denominator, it's not a sum anymore. It's the difference between the two. Excuse me, basically the two factors that p is multiplied by. And then algebraically, we get 39 divided by 866 minus 125. That gives you 52.6. And that is it for problem 66.